Welcome back to The Explainer. Today we're looking at a pretty wild collision of two totally different worlds. We're taking the ancient, traditional practice of farming and watching it crash head-on into cutting-edge AI, machine learning, and sensor technology. Honestly, it's a complete paradigm shift, and it's going to ultimately impact everything from global food security to the actual prices we see at the grocery store. Let's dive right in.
Look, I want to immediately hook you with a massive statistic here. 70%. By the year 2050, we're going to have nearly 10 billion people on this planet. And to feed all of them, global food production needs to increase by an estimated 70%. That is just a staggering logistical and biological challenge.
To hit that 70% target, traditional farming, which, relies heavily on manual visual inspection, treating the herd as one big cohort and only reacting after a problem pops up, it simply isn't going to cut it anymore. We're moving to a whole new paradigm called precision livestock farming, or PLF. This means continuous AI monitoring, tracking every single animal individually and making real-time proactive interventions. This technological shift isn't just a nice idea. It's absolutely non-negotiable.
So here is our roadmap for today's explainer. First, the precision farming revolution. Then, classifying livestock technologies. The advantages of PLF, the disadvantages and adoption risks, costs versus economic returns, and finally, future trends in smart agriculture.
All right, Section 1, the precision farming revolution and meeting that global protein demand. We really have to modernize, because research projects that under our current traditional management setups will actually only be able to meet 41% of the global meat demand by 2050.
Just to make sure we're all operating from the exact same baseline here, let's clearly define PLF. Precision livestock farming is basically the integration of advanced technologies. Think IoT sensors, machine learning, automation to facilitate the continuous, real-time management of animal health, welfare, and environmental impact. We're essentially shifting from manual observation to a highly precise digital infrastructure. And if you think this is just some niche sci-fi concept, think again. It's an exploding multi-billion-dollar market. Valued at roughly $5.52 billion in 2025, it's projected to surge to $8.36 billion by 2030. This is a massive economic engine, and it's being entirely driven by this pressing global demand for dairy and protein.
Moving to Section 2, classifying livestock technologies, or basically where the tech literally meets the animal.
It's kind of fascinating to look at how we categorize these sensors based on where they actually sit. First, we have on-cow, or wearable sensors. These are your smart collars, ear tags, and leg bands that track spatial movement, rumination cycles, and estrus. Next, we have in-cow, internal sensors, like rumen boluses. These are actually swallowed by the animal to monitor core body temperature and internal pH from the inside out, which is pretty wild. Finally, off-cow, or non-attached sensors. This means 3D cameras, walkover scales, and bioacoustic microphones, analyzing everything from a pig's vocalizations to the overall climate of the barn. Literally every variable of an animal's life can now be digitized. But, just capturing data is only step one. There are 4 distinct levels of PLF integration. Level 1 is just raw sensor data capture. Level 2 uses algorithms to interpret that data, like turning raw accelerometer signals into a known grazing or resting state. Level 3 integrates that data into a holistic view of the entire herd. And Level 4, well, that's the holy grail. Actionable decision support, where the AI actually gives the farmer direct economic recommendations. But here's the catch. Most commercial tech right now is actually still stuck at levels 1 and 2. Section 3, the advantages of PLF and how it's transforming animal health and efficiency. Talk to farmers and veterinary experts, and there's a clear consensus. PLF completely shifts veterinary care from reactive to proactive. Instead of waiting for an animal to show visible, obvious signs of illness, the AI detects really subtle behavioral changes, like the early onset of lameness or postpartum disorders, literally days before human eyes could ever catch them. Faster interventions mean lower stress for the animal and, honestly, huge savings on veterinary bills.
And the operational gains here are just wild. Early AI disease detection drastically lowers mortality rates. Precision feeding ensures animals get the exact nutrients they need, which optimizes feed conversion ratios and cuts waste. Over in dairy, automated robotic milking systems reduce labor costs by about 15%, while simultaneously increasing milk yields by 8 to 12%. And out in the pastures, GPS tracking is actively preventing soil degradation and overgrazing. These precision tools are consistently maximizing output while minimizing resource waste.
So, that brings up a pretty obvious question, right?
If the benefits are so incredibly clear, and the tech is this good, why is widespread commercial adoption still so limited? Let's pivot away from the hype for a second and look at the harsh realities on the ground.
Section 4. Disadvantages and adoption risks. The actual hurdles of high-tech farming.
Because, as you might guess, plugging a farm into the matrix isn't exactly straightforward. Research maps out several key barriers to PLF adoption, and the hurdles aren't just technical. They are deeply organizational, financial, and even tie into major concerns over data privacy.
Let's break down these roadblocks. First, the massive upfront capital investments effectively block smallholders from even competing. Second, you can't really have cloud-based AI without the internet, and there is an absolute deficit of high-speed broadband out in rural areas. Third, we see severe vendor lock-in, where disconnected proprietary data silos simply refuse to talk to each other. Fourth, and this is a bit of a visceral irony, poorly fitted wearable sensors can sometimes cause physical discomfort or stress to the exact animals they're supposed to be protecting. And finally, experienced farmers are often alienated by the black box of AI. If they don't understand how an algorithm is making a decision, they are not going to trust it with their livelihood. All right, Section 5. Costs versus economic returns. Looking at the strict financial reality of smart farming.
Despite all those massive headaches we just discussed, the math is still incredibly compelling. PLF technologies yield a highly attractive average return on investment of about 25%. Which means the payback period for all this expensive hardware is typically just 2 to 3 years. And what's driving that rapid return? It's massively driven by reduced feed and labor costs. Actually optimizing feed makes up nearly 60% of the overall efficiency gains. Since feeding is the single largest variable cost in livestock production, using sensors to perfectly tailor that nutrient delivery pays off the hardware incredibly fast.
And when you break that ROI down across different subsectors, dairy and swine are seeing the absolute fastest returns. We see these rapid payback periods largely due to the immediate financial impact of automated milking systems, slashing daily labor, and precision feeding completely transforming feed conversion ratios for swine.
Section 6. Future trends in smart agriculture. Where does AI and farming go from here?
Well, the horizon of agribusiness is moving toward fully connected ecosystems. Over the next decade, we're going to see the widespread adoption of autonomous monitoring robots actively roaming the barns. We'll see an expansion into truly predictive, cloud-based farm management. You'll definitely see tighter integration of bioacoustics, again, literally listening to the herd, tied directly into automatic environmental climate controls. And vitally, there's a huge heightened focus on ESG frameworks, using this digital traceability for highly accurate carbon accounting, meaning the very food on your table will come with a precise, verifiable carbon footprint, which is totally going to change how we all shop and consume. But you know, as we race toward all this automation, there's a really poignant quote from the research that stands out to me. Technology must aid and complement good stockpersonship rather than replace human care. It really grounds this high-tech discussion back in the timeless ethical responsibility that farmers have toward their animals. Which leaves us with one final, pretty profound question to ponder. As these systems become smarter and more autonomous, will the future of precision farming empower the human touch, giving farmers more time to actually care for their animals? Or will it slowly automate that human connection out of the pasture entirely? It's a huge question for the future of our food. Thank you so much for joining me for this explainer, and as always, keep learning.